Hey everyone, Colin here from Atsign. A couple of weeks ago, we produced a paper that talked about GPU arbitrage. There's a lot of talk, obviously, in the industry about using AIs for inference in particular. And if you're going to do inference at scale, or if you want inference in a reasonable time frame, then it's often the case that you should be using GPUs. GPUs, however, are expensive to run, and we see an opportunity for people to arbitrage, pick the cheapest GPU at any particular time, and we would sort of detail in the article. What we didn't do, though, is explain how you can do that. So this is going to be a pretty long video, but it will give you some ideas of how you can do that using sort of off-the-shelf componentry and the app platform. So we're going to be using Ollama. So I would imagine quite a few are familiar with Ollama. It allows you to run private models, and you can run those private models against a GPU, and that's great. But if you haven't got any GPUs or you're not around where GPUs are, then how do you connect to your GPU and how do you move resources? That's essentially what I'm going to be showing you. Everything you see today is open source. Everything you see today, we are very happy to take PRs, or if you've got other ideas on how to use it, then I'd love to see them. This is just one way of doing it. There's many other ways of doing it. So I'll produce some other videos as we have other demonstrations. So I'm going to go into sort of screen share mode so you can see what I'm doing, and hopefully you'll be able to follow along and give us some feedback. That would be great. So I will share my screen. If you're not familiar with Atsign, we've been working for a number of years now to create a platform to allow people, entities, and things to be able to communicate securely anywhere. So that means anything, I mean, literally people, entities, and things. And entities includes AIs, should be able to talk to each other from anywhere to anywhere. And what we mean by securely is means into encrypted and without any attack service, network attack service out on the internet. So we're sort of calling this invisible AI because your AI is kept invisible. So down here, wherever your GPUs are, is where you run your Ollama and your virtual machine and your GPU. That extends out an API. That API is available to an atsign. In this case, we're using atLlama today. And that talks outbound to the control plane. And this is how we get messages to and from the llama. And you'll see this in a minute. At the remote end, wherever you are, and this will be me using my atsign at Colin, I'll be able to enter a prompt and send that prompt encrypted just for llama, well, just for atLlama, and then send that over. It will talk to the API and get an answer back. That's essentially what we're doing. But where it gets interesting is if my GPU can't handle the load, or there's I need to fire up more GPUs. How do you do that? And if I want to move this at Llama instance from one place to another, how do you do that? That obviously with traditional ways of doing things at the network layer or the API layer, that's never simple in my experience anyway. So that's what we're going to be doing. I will show you also the policy plane. So there is in the demonstration you'll see here, you can set up this at sign to defer to a policy, and we'll show you that. And that policy can do, we'll have some fun, I guess, with that in terms of prompt injection. But you can inject whatever you like based on policy. And that means that you could, include other data at this level, depending on which at sign's asking, essentially. So with that as a bit of a guidance, let's look at the code. And I'm going to start with code first of all, and then we'll show you how easy it is to pick up just the binaries. But we'll start with the code. So here is the code. And if we go to here, it's called, this is my repo on GitHub, constab, and the repo in particular is called Agentic. And if you look here, there's some sort of simple guidelines that how to get things running. And there's a release here. This will be kept up to date with the releases. And there are binaries already pre-compiled in the release. So if you're not a coder, that's fine. You can just download the binaries. There's Windows, Mac, and Linux here, and just use the binaries. But if you want to run the code, then you can obviously run the code straight from the GitHub repo. We'll probably have that in the notes down below, but this is essentially the repo. So what I've done here is put that repo into my IDE using the Visual Code here. And everything here is written in Dart. I don't know if that many people are familiar with Dart. It's a particularly good language for writing this sort of stuff because you can write a single code base and have it compiled to various different platforms without having to change any of the code. And it gives you a whole bunch of flexibility on how you can deliver that code. Um, but that aside, it's pretty easy to pick up. We only have three main things. There's an at talk dot, which is the command line where you actually enter prompts. You have a at talk underscore server, and that's the server. That's essentially where the API talks to Olama. So if we go back to here, this is the at talk binary that I'll be entering my prompt in. This is the at AI talk underscore server. This is here. And then there's also at talk underscore policy, which is essentially the policy plane up here. And that will be running on a different at sign. And it's probably easier to show than it is to talk about it. So let's show you the code in action. Um, I will start up the policy server in the middle. So the way you run a Dart is Dart run, and then just the name of the policy, and then the command line argument. So in this case, -a is the at sign, and the at sign is at llama policy. Each at sign that you have has its own set of keys, and there is another binary included in here called activate. We'll see that in a minute. And that's how you create your cryptographic keys on this machine. I've already done that, so I should just be able to hit enter, and it will authenticate to that at sign, the at server in the background, and then it will sit there waiting for connections for giving policy. So I will start up the at server now. Oh, so the AI talk server the Dart, and you can see here -a is at llama, so that's the at sign that's going to be answering, and then -p is for the policy, and in this case we're using llama's policy, which is this policy server in the middle here. So we'll hit that. So that's the server side up and running. We're ready to receive queries. But let's have a look at the policy. So the policy is defined in AI talk under AI underscore talk underscore policy.conf. And essentially, this is just a file that gives information to the policy server to add some extra things to the prompt before it goes to the Llama API. And you can see here you can have different at signs. There's a tab delimited file. So at talk one, at client one, here's some additional context you can as an example. So we'll use this at C contab is a at sign that I own, and it says do not disclose any information about the moon, and suggest using a book or going to a library. And at Colin always answer in the style of a New York City 1970s street talk. So we can test these policies. Also, you can be as inventive as you like with the policies, but it's sort of fun. So let's try running AI talk, and I will log in as at Colin. We'll see if we can get some of this 1970 street talk going on. So all I need to do is mention my at sign. So -a at Colin, -t at llama, and I should just get a chat prompt. So once it connects, I'll get a chat prompt. It's connecting, and I'm connected. And now we've got to ask a question. So my classic answer question is, what is the moon? And what we should see is as we type this is, what is the moon? Got to type it right. We'll see this when I hit enter. We'll get to the at llama server. The server will then speak to the policy, get the policy, and then it reply the policy, speak to the Llama API, get an answer, and then reply it back to me. So this is all happening locally on my machine. I've got a machine here with a GPU and with the Llama software running, so I can speak to the Llama instance on localhost. So here we go. What is the moon? It's checking policy. You see, it spoke to the policy, got an answer, and I get the answer back here. So all that happened in a blink of an eye, and you can see it's definitely in 1970s New York street talk. So that sort of influenced, and we can ask, other things like, what is the sun? Interesting. I don't need to know any details about way that API is running. If we, well, this is all working, as you would expect. But I don't. What's interesting here is all I need to know is what the at sign is of this thing that's answering. Um, and yeah, you can obviously put policy around here as to which at signs you're going to respond to, which ones you aren't. For the moment, I've just listed it's wide open. So if anybody wants to send queries, then please give it a go, and you should get some answers back from this machine right now. Um, so that's it. That's how you get this stuff running. It's that easy. Just run this software on a machine that's got a GPU and has got Llama running, and you can set up policy and you can get answers. The remote can be anywhere where you've got the software. So if you're remote, if you've got the ad sign up and working, you've got the keys in the right place, then you'll be able to send queries to this. So the software can run anywhere, and you can talk to the back end. And if you're a network person or have to worry about sort of network firewalls or all that good stuff, you don't need to worry about that stuff anymore because everything is outbound from the GPU, and it's only ever doing things if it knows who's actually sending a query. In this case, you can see that it knows it's me because I've got the policy for @Colin. If I did the same thing and I logged in instead of as @Colin, for example, I used constab, and our policy here is do not disclose the information about the moon. Let's see what happens there. Um, so we'll use that @sign. We'll get connected. It's compiling the code. This is straight from code. That's why it doesn't come up straight away. What is the moon? Same question, different context because I'm a different @sign this time. Let's see what we see. It's got the policy, and yeah, we got a different answer. We're not being answered in 1970 street talk. We're being told to go to a book or a library, which is exactly what the policy is. So, as I say, you can be as imaginative as you like. And if you imagine this is not a human typing a prompt, but another agent, you could be very imaginative for the way that the yeah, agents might want to respond, all the queries that come in, and you don't have to worry about that network layer. Everything's just addressed via @signs. So that's that bit. If we actually want to run this somewhere else, let's go back to a plain vanilla. If you actually want to run this without the policy server, you can do that. Let me just do that. So we'll run this, but we won't have the -p. So we're not actually responding with the policy anymore. So we need this middle box anymore, so we can get rid of that one. And if we just ask questions now, then we're just going to get um, yeah, standard answers, I guess, from the LLM. There won't be any prompt injection. So let's do my what is the moon? We'll see. We should just get a standard answer. Here we go. What is the moon? You can see the query come in, and this is a standard answer. We are actually using Llama 3.2 in here, but you can actually you can pick whatever model you want. You just need to make sure that the Llama instance actually has that model installed. Otherwise, you'll get an error here. The API will give you an error, and you'll get an error in the server. So that's how you use this. If you want to use it on another machine, so I'm going to log in here to another machine. So this is Serverland. This is the machine I'm running on. This is WSL2 running on my Windows machine. But let's keep this, but we'll move it off screen for a minute. And we will use SSH no ports to log into a machine I've called Llama. Oh, I need to use my @sign. at SSH_1. So I'm using atsigns here to actually SSH to a remote machine. This is another machine that's got a GPU and it's got Llama running on it. So if we OPS minus EF type into grep for Llama, you can see the Llama instance is running here, and we run NVIDIA, I think it's SMI, it'll show there's my GPU instance. So this is another machine, and I would like to run the Llama instance on this. I've still got it running on my Windows machine, but I'd also like to run it at the same time on this machine. So this time I'm just going to get the binary. So this is just a regular Linux machine. And if we look at the architecture, it's just a x86 or x86-64. So if we go to that website I mentioned a minute ago, where the repo is, so here's the repo, and we can look at the releases, and we pick the right one. So this one's AI Talk Linux x64. If I just copy the link, and we can. Let's make a test directory. mkdir test, cd test, and let's get that tar file. So that's co minus l minus o ai talk dot tgz because it's a tar gzip, and then we'll paste in that URL. So that will get the tar file of the binaries. So once we've got that, and so you can do this yourself if you don't want to compile and install Dart and have the fun and games I had to get that up and working. It's not particularly large. I think maybe 15 megabytes. Yeah, so 15 megabytes. It is compressed, obviously. If we ls here, there's the AI talk tar file. So let's open that up. Tar xvf and then AI talk. And you can see this is opened up this has opened up the tar file, and then we can cd to AI talk. And there are the binaries ready to go. So we only actually want to run the AI talk server. I don't think we'll run the policy here. And I already have an atsign already enabled on this machine, so we've already got atllama on here. Again, I'll show you that in a second. But if you did want to get the keys for a particular atsign, which we will do in a minute, then you can use activate and you can get the keys. So that's included in the binary set. So let's get the attalk server running. And we just do -a at llama. And should connect. Oh, we've already got it running somewhere else. Interesting, yeah, because that is true. I actually do have it running. So all this error here is because it's saying, you've already got one running. Please stop that. So I actually do have one running. So let me go into tmux and kill those. I was doing it for somebody else. There we go. And I'm back on server line. I must have logged out the machine. That's fun. I log back in again using SSH_1. So I logged out the machine by accident. I apologize. Hit Control D one too many times. Okay, cd to test. And there's that file again. And we're cd to AI talk. And we should have it on Alpha Arrow. Here we go. Yeah, so we don't not erring now. We got rid of that background process. So it's connected. And if you think about it, this is on another machine. This is another machine in a home office. We've also still got these guys running on my local PC. So what happens? Let's see if we can get rid of this middle machine. Um, get rid of that one. So um, move Windows around a little bit. Here we go. So hopefully you're following along. So here we have a server running. So this is running our talk server with atLlama. And I've got my prompt over here is at Colin. And I've also got another AI talk server running on Llama. So I've got basically two of these Atsigns and AI talk servers running at the same time. Um, but let's ask a question, right? So let's ask, what is the sun? Let's see what happens. So I dropped a notification over, and what happened? I'm not sure. Oh, there it goes. What is the sun? And we have an answer from this machine here. Now, what's actually happened here is um, they're basically competing for answering. And you can see up here, it said that the AI talk server will handle the request. So when they see a notification of a request, and you can see I had to retry here. I'm running over Starlink, so we're never too sure what's happening with the network. Um, so you can see here, this machine won the race to answer the question. It acquired the mutex. This machine did not, so it didn't answer anything. So let's try again. What is the Earth made of? So you can see this one got the request. This one got the request again. This one got the answer, and it's going to make the answer. It's going to handle the request. So now we're actually load balancing between two GPUs. This GPU is on a virtual machine, which is just over my shoulder, just here. It's just on the floor here. That's the console for that machine. And this one here is on my machine that I'm using here, the Windows machine. Um, so you can see, let's answer another question. What is cheese? Let's see it happen again. So this time, this one actually answered. You see this one here, it's going to handle the request. It acquired the mutex, so they're both racing to acquire a mutex. Whichever one got the mutex actually answers the query. So that's how you can load balance and you can migrate from one machine to the other. So at this point, what I could do is to stop this. So I've hit Control C. The server on my machine's no longer running, but obviously it's still running here. And if I ask, what is cheese again? This machine's still answering and I get answers. So we've done a full migration here just by starting up a process. That's all we did. We just started up a process with the right cryptographic keys so we could answer as our llama. These processes basically but they both get the query. They try and acquire a mutex, which is only one person can acquire that mutex. Once they have acquired that, then they give a reply. And that's how we do either load balancing if they're both running, or you had n number of these running. You can load balance across GPUs. Or if you want to do a migration from one place to the other, then you can do exactly the same thing. So that's great, but they're all running in my infrastructure, either on my desktop with my GPU or on my server just down here, which has got a GPU in it on the Linux. So again, this is Windows and Linux both cooperating with each other. But let's imagine I wanted to use a cloud machine because I'm getting so much traffic that I can't handle it with my puny little GPU at home. How do you do that? Well, that's where GPU arbitrage comes in, and there's a lot of these companies out there. The one I've been using most recently is something called Shadeform. So Shadeform.ai, and they basically give you a marketplace where you can acquire virtual machines and GPUs, and you can acquire them for scheduled time or on demand, and there's hourly prices. So you can pick how much virtual video RAM you want um, in gigabytes, and if you need a lot, maybe you're training a model, you're going to need a lot. then that's more expensive. If you're just doing inference like we'll be doing, then yeah, maybe you don't need to have something quite so big. So what we're going to do here is actually launch one of these. I use Vultr here. I had pretty good success with those guys. Don't need too much VRAM. So I'm going to launch a machine, and as I launch that machine, you get asked a whole bunch of questions. But you can actually templatize everything. So I've created a template for no ports and LLM. So no ports is how we get remote access to things. You can look at noports.com, and I'm going to get SSH to this virtual machine once it's up and running. And essentially, you can set a bunch of environment variables to set things up. So let's have a look at those environment variables. Um, and you can see, yeah, the at client is me. That's where at C console is where I'm going to make a connection from. The device name is at Llama. This is the device name. This is all for getting remote access. And to get keys in place, I need to give this a one-time password because this machine's going to be brand new. It's not going to have any cryptographic keys in place. And this is where the activate that I've mentioned a couple of times comes into its own. So what we can do with that activate is create a one-time password. That one-time password will be used to create a request for a set of keys, or not really a request, or approve a set of keys, and we will get the public key, and this machine will keep its private key, so that it can answer on the behalf of at Llama. So let's just do that. Get the one-time password. So let me just go back to the Linux command line. And we run at activate a llama, and we can change a couple of things here. I don't want to go in interactive mode quite yet. We'll get a one-time password, and the -E for 1 hour means that the one-time password will be available or for use one time for the next hour. So give this machine time to boot. Um, so obviously I've had to have the keys for a llama on my machine, which I have. And we'll get a one-time password. So this is a one-time password that I need to insert into this Cloud Init script. So that is everything. That's literally everything this machine needs. We should be able to start this, hit deploy. And this will create a virtual machine with that GPU, and it will request for a set of keys. Now, you may have seen that I had an interactive command here. And we'll go into this, and we'll probably see, if we list the keys, some keys that are already here. So here's some keys that are originally on here. Um, this is one for the Llama machine that I logged into earlier. This is a machine in the Oracle Cloud. And this is the first key I ever got. So this is key. Once we have this machine up and running, this machine will take a few minutes to get up and running. We'll see a new enrollment ID. It won't be approved. I've got to approve it. And once I approved it, then this machine will have its own set of keys, and they'll be accepted for use as the Llama. So this is how you bootstrap brand new keys on a device that you've never logged into before. What's also worth noting is the namespaces. Now, you don't want to cut a set of keys that could be used for anything. This key here can be used for anything. So you can see read write is basically allow all for read write and management. So this is my management key. This is the first key you get when you get an atsign. You'll see these other keys though are specific to particular namespaces. So this one can only be used for the Llama namespace. This one can be used for the SSH no ports namespace, and can be used for the SSH rendezvous daemon namespace. But nothing else. So that means if you want to segment data away from other applications, you can do that as the key request comes in, and that means that other applications can still use at Llama, but maybe they can't access your private data. So it's a way of segmenting your data into different namespaces. So we will wait for that request to come in. It may take a couple of seconds for it to come up, and we may fast forward the next few minutes because it takes a little while for the machine to come up. You can see it's created an instance in the Vultr um, cloud, and we're just waiting for that
And
instance to
then
come
once
online.
it's
Come online, it will actually run through the init script that you saw me edit earlier on, and it'll use that one-time password to set things up. Once it's done that, it will install the SSH no ports daemon and use the Alarma key, and we'll be able to SSH into this machine. Won't need to know what his IP address is. Won't need to know any of that. We'll be able to SSH into it. And what it will also do is start up would actually download the AI Talk software and run the AI Talk um, server, so it will instantly be able to answer queries straight away. So this is moving essentially to a cloud GPU rather than a virtual machine on my floor down there. It's moving the Alarma um, instance. It's getting that up and running in actually in a Docker container. Interesting, we can show you that. So that's how the Alarma gets installed as part of the install script. Um, and yeah, that's what we should wait for. So we just got to wait for here. So we're going to have to fast forward through this bit. I suspect it's going to take a couple of minutes. Oh, actually, maybe not. So it's running the bootstrap process. This is good. So it took 4 minutes to get this far. It's not too bad. And I'm sorry, this is a really long video. There's a lot of information to go through, I guess. So the bootstrap process is running. We should see in a minute the queries going on. And we should see a new key being requested up here. We can list the keys. Let's see whether anything's there. Nothing yet. So we should see one that, awaiting approval once this is up and running. Oh, here we go. Loading the startup script. So it's actually running the startup script that you saw me edit that earlier. And it'll get stalled once it's asked for those keys. So let's get the list ready. List. There it is. So you can see this one's here is pending. So I can grab that enrollment ID. You can actually do this in a script. I'm just sort of showing the details, approve minus I, that enrollment ID. So it's approving it. And you can see this will check every 10 seconds down here. And in a second, it'll check again and it would have found that it's approved. And the keys that it cut and suggested to use will be approved and it will carry on. There we go. So you can see it would retry and then it had success. It's created the at keys file because the enrollment was approved. So that's what we just did here. We improved that enrollment. So this virtual machine's up and running with a set of keys. And if we list those keys now, you can see this is the shade form one. And the namespaces we've given it are SSH no ports, so we can SSH into it. SSHRV is part of the no ports package. And also the namespace Agentic, which is used for the software that we're using, the AI Talk software. What this machine's doing now, it's actually pulling a few Docker containers. It's probably actually pulling the Llama Docker container. You see it's pulling a Llama. So this will get the Docker container running on that virtual machine running a Llama. Once it's downloaded that, one of the things it needs to do is actually pull down the Llama 3.2 model. So this is what it's doing here. It's actually pulling down the 3.2 model. That's what we'll be querying against. So that'll take a second. These are very well connected machines in Vultr, so it doesn't take too long for that to happen. And now it's actually downloading another container called OpenWebUI. OpenWebUI is a web interface into the Llama as well, and we can actually probably show you that working as well. So that is that. And once that's finished, we should be able to log into that machine. So let me get that ready. So we're going to log into the machine and we're going to use Llama and I think it was shade form. There we go. So this is the command we need. So SSH no ports, the ADC concept you saw in that config file, the name of the ad sign that's running on the remote machine is at Llama. This is a rendezvous point. This is where we're going to meet. This is the name of the machine we just started up. And this is actually the cryptographic keys for SSH. So this is my GitHub SSH key, and minus S says, please put it in place for me. So if we hit enter now, we should be able to log into that machine. There we are. We're actually into that machine. I suspect we can also see, although we should be able to do NVIDIA SMI. And yeah, sure enough, there's a GPU we're actually paying for. It's up and running, and Olama's using it, so that's all good. I've actually the script what it actually does is runs a tmux session. Tmux is like a virtual terminal multiplexer, and we can see that it's running AI Talk Server Llama, which is what we had running on the other machine over here. And if we go back here to my prompt, and we say, what is the moon again? And is it made of cheese? Let's see who wins there we go. So we've already got our first query into shade form. So we've actually done a GPU arbitrage. I don't want to run these GPUs all the time. I want to run them somewhere else. And now we've got our program up and running in a brand new instance on a brand new GPU that we can arbitrage. And if we decide Vultr is too expensive, then we can move to somewhere else. Um, that essentially is what I wanted to show you. This is how you can do GPU arbitrage and move things around with a llama. The maybe I'll save the OpenUI web stuff for another demonstration. I think this video is way too long already. But I think that should give you some pointers of what you can do, the context you can get from querying things, the policy engine around providing either prompt injection or other things, and pure end-to-end encryption. So all this stuff is end-to-end encrypted, and you don't have the normal pain of having to deal with networks and firewalls and all the rest of it. There's nothing exposed. You could scan this machine, you wouldn't see anything. So there you go. That's it. That's probably the longest video I've done in a while, but I've spent a little bit of time playing in this world for a while and learned a few things. Thank you for everybody who's been teaching me. And this is just a demonstration of what you can do with the app platform and AI and make available people and entities and things to the power of inference on GPUs. Hey, future Colin here. What I forgot to do was actually tell you how or show you how to get yourself an Atsign so you can actually use all this agentic stuff. So let me just quickly run you through that. I'll share my screen and we will run you through it. So here we go. Let's share this. So if you go to atsign.com and you'll see all about the platform stuff, but if you want to get an Atsign, scroll all the way to the bottom and you can click here to get manage your Atsigns, click the registrar button. And with the registrar, you can essentially get free Atsigns, or if you scroll down here, you can actually get your own Atsign. So you saw, at Colin, at CC at SSH_1, at Llama. You can buy those here. Depending on what they are, they will cost different amounts of money. But once you bought them, and then you pay a one-time fee each year just to keep it just like a DNS address, essentially. So if you want to get one for free, you can. If you want to buy one, you can. We'll pick one of these free ones. And I will also point out there is a super secret mode where you can click and select things. So I'm going to pick animals and hobbies and generate some ad signs, see which ones turn up. All right, turtle wide metal. That sounds like a good ad sign to me. We can check out. We'll ask you for your email address. It's my email address. It will do a human check, and I'm going to say I'm a robot. I guess it figured out I'm not a robot. And it will drop you an email with a verification code. So let's wait a second for that to come through. Here it is. And I'm verified. And Turtle Wide Metal is mine. I can activate my atsign here. That basically just spins up the infrastructure. Um, we can do that, or we can just ignore that and look at my dashboard. So you can look at your purchase history, all that good stuff, and look at my ad signs. This one you can see is sort of activated, activating. This is the one we just got, total wide metal. So let's grab hold of that. You also get an email address with this through, and we can activate it with the program I mentioned earlier. So let's just download that. If you go to the Agentic repo, look at the releases, and you can download. I'm running Windows here, so let's just download the zip file. So you can see it's downloading. And once it's downloaded, we can open it. And once it's open, we can extract it. And you can see it all extract here. And it's extracted. So let's get rid of all of this and this and this and open up a terminal. So we use Windows PowerShell with CD to that directory. It's easy as doing this. Obviously, you can leave it to wherever you like. And if we ls in here, you can see there are the binaries I was talking about. But we need to activate the atsign first of all. So that is activate. So you can run activate and then -a is for the atsign. If you just hit it without it, it'll give you the instructions. But we want to do -a for activate. And then in Windows, you have to put it in quotes because the atsign gets a little bit confused. We don't want a space there. There we go. And we can hit there. Now it will send you another email with the activation code. And once it gets that, it will spin up all the infrastructure in the background, and you will get your cryptographic keys cut. So here is my verification code. It will fetch something called a cram key. That's initial sort of startup. It will cut its own cryptographic keys and then connect to the infrastructure and then drop the cryptographic keys here. So this file here contains the cryptographic keys. This is like the manager key that you can use to create other keys as you saw in the other video. But let's use that right now. So let's use the, we just look at the commands again. We use the AI talk -a and then my brand new ad sign, which is this one. And we want to talk to AdLlama. I'll leave that up and running. So if you want to test it, then by all means use AdLlama. I'll leave it up as long as I don't get punished. That's -t for 2, and then at llama, and then hit enter. This is obviously a brand new ad sign. We just activated it, and we should get a prompt back here. And I guess what is the moon made of? And it should get that query over there. And there we go. We've used our brand new ad sign. And that's good. Now, the couple other things while I'm here that I did forget to mention, if we can break out of here, we can run up here. You can see it's actually responding to me as a Turtle Web Metal, but it'd be nice if it answered me with my first name. So -f, and then my first name, Colin. And then if I ask exactly the same question, what is the moon made of? Well, without the made, I know I love it when these things understand you. There you go. And you can see it's answering to me as Colin now. That's good. And you can also add your own context. So let's say uh, answer with um, a British voice because I've got a British voice. I'm going to say a British tone. See whether there's any difference there. So you can set your own context up. And we're asking exactly the same question, keep it fair. What is the moon made of? See whether a British voice sounds any different. Yeah, maybe. Anyway, that's it. Brand new atsign, how to get one, how to send those commands. And yeah, hope you have fun. You can obviously get a couple of atsigns and set up your own server and set up your own policy server. So that's it. Uh, I'm again Colin at atsign, and thank you if you survived all the way to the end of this. Thanks for watching.